Welcome to The Explainer. Step into the Coliseum of Cambridge exams. I want you to literally imagine the scene. The clock is ticking down, the invigilator is pacing up and down the aisles, the silence in the hall is deafening, and you've just turned the page to a brutal, multi-part 10-mark question on your Cambridge mathematics past paper. We're talking syllabus codes 0580, 0606, 4024, 4037, or even 4040. It doesn't matter which arena you're in, the rules of combat are exactly the same. Only the prepared survive. Now, here is the secret most students never figure out. Mastering Cambridge mathematics isn't just about crunching numbers or memorizing formulas. It's actually about decoding the highly precise, almost legally binding vocabulary of the exam itself. Most students think math is just numbers. It's absolutely not. It is a language, a very strict language. And today, we are going to master the strategic code to unlock your absolute highest grade. To do this, we are going to look at two hypothetical students. Let's call them Alex and Sam. Now, over on the left, we have Alex. Alex works incredibly hard, but he overloads his brain with raw mathematics facts and applies absolutely zero analysis to the actual question. He sees a shape, panics, and writes down every formula he knows. On the right, we have Sam. Sam is quick, maybe a bit too quick. Sam rushes through the paper, completely missing the specific command word requirements hidden in the text. Both of them are bleeding critical marks, and their papers are covered in red examiner ink. But today, we are going to fix that completely. Look at this. This is the raw glossary sourced straight from the Cambridge syllabus. It is literally a dense, alphabetical list of over 100 terms, ranging from acceleration all the way down to y-intercept. Now, if you are like our student Alex, your strategy is to just print this out, stare at these 5 pages, and try to brute force memorize them from A to Z. I'm telling you right now, studying like this is completely 100% inefficient. You simply cannot walk into a high-stakes exam hoping to suddenly remember what a coefficient is just by relying on rote memory when the pressure is on. You need a strategic system. You need to know how these words function as instructions. I promise you, by the end of this explainer, we are going to conquer this massive list, not by memorizing it like a dictionary, but by decoding it like a master strategist. We are going to take Alex and Sam's flawed approaches, apply our system, and transform those red pen marks into beautiful green check marks. So here is our thematic roadmap for today's session. First, we'll tackle numbers and proportions. Then we dive into the language of geometry. After that, mastering data. And finally, decoding probability. Let's get right into it. Section 1. Numbers, fractions, and proportions. Okay, I want you to notice the stark contrast between two of the most commonly confused terms under exam pressure, factor and multiple. Look at the definitions. A factor of a number divides into that number exactly. For example, the factors of 18 are 1, 2, 3, 6, 9, and 18. On the flip side, a multiple of a number is the result when you multiply that number by a positive integer. So the multiples of 18 would be 18, 36, 54, and so on. In the heat of the exam, Sam sees the number 18 and the word factor, panics because the clock is ticking, and quickly writes down 36. Instant red mark. 0 points. This is where top students use the secret weapon. We call it the modified Peel framework. That stands for point, evidence, equation, and link. The strategy here is the point. Your point is to explicitly identify the command vocabulary before you even touch your calculator. Are we dividing exactly, or are we multiplying by an integer? You have to read the word carefully. By the way, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's keep building this strategy. This level of precision builds directly into fractions. We really need to break down fraction vocabulary, because knowing exactly what an improper fraction or simplest form means is the difference between an A and an A star. Let's review the basics really quickly. A proper fraction means the denominator is greater than its numerator. An improper fraction is the opposite. The numerator is greater than its denominator. Equivalent fractions are equal in value despite having completely different numerators and denominators. But here is the absolutely critical part, the command phrase simplest form. The Cambridge Glossary strictly states a fraction is in its simplest form when it cannot be simplified or canceled down any further. Now imagine a 5-mark algebra question. You do all the heavy lifting, you solve the equation, and the question asks for the answer in its simplest form. If you leave your final answer as 4/8 instead of simplifying it to 1/2, you lose the final mark. It's heartbreaking. That is the link in our Peel framework. You must always link your final mathematical calculation back to the specific vocabulary constraint of the question. This is a core part of our mathematics success blueprint. We don't just calculate, we verify our answer against the command words. So, the absolutely crucial point here is reading with extreme precision. And let me tell you, nowhere is this more true than with proportions.
Compare direct proportion and indirect proportion. The glossary clearly defines direct proportion as two quantities are in direct proportion if, when one increases, the other increases by the same multiple. Conversely, indirect proportion is when one quantity increases, the other decreases. I am highlighting this because it is a classic, notorious trap where misreading a single tiny word changes your entire algebraic equation. If the paper says indirectly proportional and you rush like Sam and use the formula y equals k times x instead of y equals k divided by x, well, you score 0 marks for the entire multi-step calculation. The vocabulary word itself dictates the algebraic evidence you must use. If you get the word wrong, the math doesn't even matter.
Let's move on to Section 2, the language of geometry.
In geometry, you aren't just given numbers, you are given words that represent numbers. Think of it like a translation exercise. I always tell my students to use 90 degrees as your anchor. The glossary is very specific here. A right angle is exactly a 90-degree angle. An acute angle lies strictly between 0 degrees and 90 degrees. An obtuse angle lies between 90 degrees and 180 degrees. And let's not forget a reflex angle, which is between 180 degrees and 360 degrees. Now, when our student Alex sees an angle that looks slightly bent in a diagram, he just guesses based on how it looks. Never, ever do that. The diagram in a Cambridge paper will almost always have a tiny disclaimer saying, not to scale. You cannot trust your eyes in this arena. You must rely purely on the vocabulary in the text to determine if an angle is acute or obtuse, and then set up your equation accordingly. Now look at this table of triangles. This right here is where the magic really happens for top-tier students. An equilateral triangle has 3 equal angles, all exactly 60 degrees, and 3 sides of equal length. An isosceles triangle has 2 sides and 2 angles equal. A scalene triangle has 3 sides of different lengths and 3 different angles. I really want to emphasize something massive here. If an exam question explicitly says a triangle is isosceles, they are secretly handing you hidden equal values to use in your equation. The word isosceles is the evidence in your Peel framework. It's literally the examiner giving you a free equation, but only if you know the exact definition to unlock it. Sam reads isosceles, skips over it, and gets stuck because he thinks he doesn't have enough numbers to solve for x. The word was the number. Let's keep building on this. Cracking the polygon code is absolutely essential. A polygon is simply a closed 2-dimensional shape made up of straight lines. A quadrilateral is a specific 4-sided polygon, but here is the million-dollar distinction that separates the pros from the amateurs. Regular versus irregular. A regular polygon is a shape where all angles are of equal size and all sides are an equal length. An irregular polygon does not meet these criteria. Let me clarify why this critical difference matters so much. If you are asked to calculate the exterior angle of a polygon by dividing 360 by n, you can only use that specific formula if the word regular is printed in the question. The word regular is what makes that mathematical shortcut possible. Without it, you are lost. Look, if you want to master these hidden tricks, stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, it's time for our first interactive workshop challenge. I want you to contrast congruent shapes and similar shapes. The glossary is incredibly precise. Congruent shapes are exactly the same shape and size. They are identical. Similar shapes mean corresponding sides are in proportion and corresponding angles are equal. They are basically enlargements of each other. This distinction fundamentally changes how you approach transformation and geometry questions. Now let's play Find the Flaw. Sam wrote this answer on his mock exam. To prove the triangles are congruent, I calculated the scale factor and showed the sides are proportional. I'm giving you a few seconds. Spot the flaw? Time's up. If a question asks to prove congruence, you need to prove exact identical lengths using criteria like side, 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 or side, angle, side. Sam just described similarity. Sam lost 4 marks here by proving similarity when the command word was congruent. You have to read the prompt.
Let's do another quick challenge. Speed writing. I'm giving you 30 seconds to mentally draft a perfect Peel paragraph based on circle geometry. The glossary defines a sector as part of a circle that looks like a piece of pie. It is enclosed by 2 radii and part of the circumference. Remember your supporting vocabulary too. The circumference is the perimeter of a circle and the diameter is a line which passes through the center and joins 2 points on the circumference. Knowing the difference between a sector, a segment, and an arc is simply non-negotiable for those heavy 6-mark mensuration questions at the back of the paper. If they ask for the area of a sector and you calculate the area of the whole circle, well, you know what happens.
Moving right along, Section 3, Mastering Data and Statistics.
Statistical terminology is brutal because it often trips up students before they even touch their scientific calculator. You can be an absolute genius at arithmetic, but if you don't know the definitions, your graphs will be entirely wrong. Here is our data scan challenge. Look at the stark contrast between discrete data and continuous data. The glossary states, discrete data does not include any in-between values. It has gaps. Think of shoe sizes or the number of people in a room. You simply can't have half a person or a shoe size of 7.34. Continuous data does not have gaps in the possible values. Think of height, weight, or time. Now, why does this matter so much? Because this exact vocabulary dictates whether you draw a bar chart with gaps between the bars or a histogram with absolutely no gaps. If the exam gives you a table of continuous data and you quickly sketch out a bar chart like Sam would, you lose the format marks instantly, even if your numbers are perfect.
Now let's try another Find the Flaw challenge with these 3 averages. We group the 3 averages like this. The mean is found by adding all data values and dividing by the number of values. The median is the middle value when the entire data set is organized in order of size. The mode is the value occurring most often. Listen very closely to this flawed paragraph from Sam's exam response regarding a survey of shoe sizes. To find the typical shoe size, I calculated the mean, which resulted in 7.34. Did you spot the flaw? Shoe sizes are discrete data. A mean of 7.34 doesn't exist on the shelf in a shoe store. The examiner commentary for this specific question states that for this discrete data, the mode or median is the only appropriate average to use. You must read the context carefully so you don't calculate this statistically wrong average just because you memorize the formula for the mean.
When defining the relationship on a scatter diagram, word precision is key. You must accurately define correlation. Positive correlation is when points are roughly in a straight line from the bottom left to the top right. As one quantity increases, the other one does too. Visually contrast that with negative correlation, which occurs when points are roughly in a line from the top left pointing down to the bottom right. Now, if the command phrase in the question asks you to describe the relationship, writing something vague like the line goes down gets absolutely 0 marks from the examiner. Writing, there is a strong negative correlation between the 2 variables, secures the full mark. Vocabulary is literally your shield and your sword in this arena.
Let's enter the final phase. Section 4. Decoding probability and events.
Probability isn't just about rolling dice or pulling colored marbles out of a bag. It is a logic puzzle where your mathematical reasoning relies almost entirely on the strict syllabus definitions of events. If you misinterpret the event type, your entire probability tree diagram will be hopelessly flawed. This brings us to the final system, the 3 rules that guarantee top marks. Rule 1 is command word decoding, Rule 2 is Peel framework application, and Rule 3 is the time management matrix. Let's apply Rule 1 to these 3 critical event types. The glossary defines independent events as 2 events where the outcome of the second event is not affected by the outcome of the first. Think of flipping a coin twice. Dependent events are when the outcome of the second event is affected by the outcome of the first. Think of pulling a marble from a bag, eating it, and not replacing it. Mutually exclusive events are 2 events that absolutely cannot happen at the same time. You cannot roll a 2 and a 3 on a single normal die roll simultaneously. Understanding these exact phrases is what dictates your math. Mutually exclusive means you add the fractions together. Independent means you multiply them. Dependent means you multiply, but you must remember to subtract 1 from the denominator of the second fraction. The English words dictate the math equations. Applying Rule 2, the Peel framework, let's compare fair and biased. A fair event means all possible outcomes have a perfectly equal chance of occurrence. A biased event means some outcomes occur more or less frequently than would be mathematically expected. This shows exactly how a single word in a paragraph-long word problem completely changes the expected mathematical model you have to build. If a question introduces a bias spinner, your standard, comfortable assumption of a 1/4 probability for 4 colors is thrown completely out the window. You have to rely solely on the relative frequency data provided in the table. If you skim read like Sam, you'll divide by 4 and fail the question.
And this brilliantly illustrates our final core concept today. In probability, the number 1 has a very specific absolute definition. If an event is certain, its probability is exactly 1. An impossible event has a probability of exactly 0. If you are doing a complex calculation under pressure and your final answer is 1.2, you have made a fundamental error somewhere. Stop. Use Rule 3, the time management matrix, to decide if you have time to recheck your tree diagram. Remember, probabilities only exist on a spectrum from 0 to 1. Now, before we wrap up, I need to tell you something important. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So, I leave you with this question. When you open your next exam paper, when the invigilator says you may begin, will you just see a jumble of words and panic like Alex? Or will you see the strategic code to your highest possible grade? Today, we've built a complete, bulletproof mathematics answering system based on decoding command words and applying our modified Peel framework where vocabulary acts as your literal point and evidence. You need to stop treating vocabulary as boring rote memorization. Start using it as your ultimate problem-solving toolkit. You have the definitions, you have the strategy. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Now step into the arena and conquer it. Keep learning, keep analyzing, and I'll see you in the next explainer.